Hey, so here we are again. Wanted to look now at volumetric displacement. So if you've already watched the video on compression ratio, we looked at a comparison of this volume at top dead center to how much do we squeeze it to, how much do we compress and squish it to, and making that ratio comparison, okay? Volumetric displacement is a little different. There's no ratio, there's no comparison. We're just looking at how much volume and how much space is moved or say brought into the engine. It's easiest to think about it on the intake stroke because we're not compressing or squeezing it, we're just bringing it in. Okay, so if you think about this and forget about the clearance volume and how much we're squishing it to, and we just imagine that this valve is opening, piston's coming down, and we're bringing in that air-fuel mixture, talking gas, bringing in that air-fuel mixture, or air only if it's a diesel, bringing in this much space. Okay, so there's our volume, right? So we brought in that one chunk of air-fuel ratio. Okay, now if we add up all those chunks for all the cylinders, that's what we would call the volumetric displacement of the engine, or how we size engines. And I say volumetric displacement because there's a number of ways to represent that space. Okay, and we can talk about it in cubic inches of displacement, which is 1 inch by 1 inch by 1 inch. Like how many cubic inches are there? We could talk about it in liters. We can talk about it in milliliters. We could talk about it in cubic centimeters. So there's lots of different ways to compare these things, and we'll look at that a little bit at the end. Okay, so let's look at an example of how we can do this. So here's an example. Calculate CID, so in this case cubic inches displacement, for a V8 engine with a 4-inch bore and a 3.48-inch stroke. Okay, so let's just say we've got pi r squared h times number of cylinders. Okay, so we want that volume for the whole engine. So pi, our radius is 1/2 of the bore. Bore is our diameter. Okay, so we've got radius of 2, and we're going to square that, so it's going to end up being 4, but of course it wouldn't with another number. And our h, our height of this cylinder, is the stroke. That's the length of travel of the piston, right? So we have 3.48, okay? And then the number of cylinders, well, it's a V8, so there's 8 cylinders, okay? And if we multiply this all out, we get something like 349.67, I believe, okay? So 349.67 cubic inches for this engine. Now, does that number look familiar? Sure. Round that up, and what do you get? You get a 350, okay? Those are the specs for Chevy's 350 engine, which has been in pretty much everything since the 67 Camaro to pretty much every truck and vehicle they've made since. So very, very common engine. 67 Camaro was the first engine that they put that in, or first vehicle they put that engine in, so just a little fun fact for you. And there's our number, okay? But you probably know that that's also 5.7, a 5.7 liter. And it's the same thing. So when we started talking metric conversions, we stopped talking cubic inch displacement and started talking liters. It's the exact same block, same bore, same stroke, same everything. So it's the same engine. So you've probably known for a while that those are equivalent, right? Or a 305 is equivalent to a 5 liter. Okay, so if we did some math and we could figure it out from this, right? So 350 cubic inches over 5.7 liters is how many cubic inches over 1 liter, right? So we could take this times this divided by this, and we would get this number here. I don't have memories, but I'm pretty sure it's like 61 or something, like 61.3 or something. So 1 liter would be 61 let's just say 3 inches cubed, okay? So we can take and kind of figure out some of those conversions, right? Similarly, what is a cubic inch? So let's just get rid of some of these things. So if we talk about that liter conversion, if I have a 5.3 liter, well, intuitively we know it's somewhere between a 305 and a 350 in terms of cubic inch displacements. If we just want to sort of compare, metric rated engines, or sorry, volumetrically described engines to engines that were described with standard measurements. But a 5.3 obviously somewhere between 305 and a 350, right? But I could take that and multiply by that 61.3. Don't quote me on that constant because I just couldn't do the exact math in my head, but somewhere right around there. So we times it by that constant that we would get, and we would figure out exactly how many cubic inches it is, likely somewhere close to like a 327. Okay. So you can do the same thing. A 6 liter, 6.9 liter, 7 liter. Figure out how many cubic inches displacement it is. Let's look at what a cubic inch is. Okay, so a cubic inch, I'll maybe do this a little bit bigger. I'm going to draw it bigger than an inch. That's a cubic inch. So it's a volumetric space that's defined by 1 inch by 1 inch by 1 inch. Okay, so you've probably heard cc's, right? Like cc's of your engine, right? So if I take a cc, well, how much a cc is a cubic centimeter? Well, a cubic centimeter is 2.5 by 2.5 by 2.5 because there's 2 centimeters in every inch. So that's a cubic inch is equivalent to this. And if we times that, I think it's like 15.6. So 15.6 cubic centimeters is equivalent to 1 cubic inch. Okay, so when you're talking like an 800 cc quad, you divide by this and then you can figure out how many cubic inches it is. Okay, so that's just sort of some of the conversions and how we represent these engines. All of them are using volume to describe size. Okay, and size meaning how much are we bringing into this engine and then essentially moving out on the exhaust stroke too after it's been compressed and burnt, but just what's that movement in and out, okay? Not the comparison of how much we squish it. So that's how you do sort of those two things. So there's a couple videos for you. All right, great.